Yes, I'm going to put the video of Nico Papania here, I hope. Yes. Because I already tried how to. I already set up the sound. Yes. Yes.
It seems to be that a lot of the focus problem is from copying all the parameters with into arrays and create new objects. Another way could be that you go to this, like something like this object and do not to copy everything, but just look in the back of the stack of the original method to look up all the arguments without creating new arrays of arguments.
I didn't. Now, asking for this context is probably also, so run within doesn't force context verification. So it doesn't force the creation of the context. So if we try to use this context, now we are forcing, so probably it's going to be slow in a different way. And my hunch is that probably what we need is a way of a tracing mechanism where actually we can specify, okay, I want to trace these methods and what they are doing. And the VM actually is just going to do really basic tracing. And then do this, so we can actually do the analysis afterwards, like I was showing before. But probably we can generalize most of the analysis that we are doing, like profiling time or profiling number of calls, or even the coverage by just tracing execution. So it's just storing in an array. This method was executed, and that's all. Yes. Because also, if you see, most of the times, it really depends on what kind of instrumentation you want. But for example, to all the analysis that I showed before, we just need the arguments to forward them to the execution of the original method. We don't need them for anything else. So, I think, I don't know, I don't want to add noise in the, this doesn't need to be recorded. Okay, so I'm going to put Nico's talk. So Nico is going to also follow on this idea of, okay. So Nico is going to talk also about code coverage and instrumentation. So it's kind of a nice follow-up. Yes.
The maximum possible volume?
I can check. Yes, yes. Maybe we need to, this is the maximum here. Command rideau, éclairage, freeze. Yes, okay. I can manage it from there. So just tell me if you don't hear.
Hello everyone, I'm Nicolás from Argentina. And today I will talk about how I built a code coverage tool that can analyze itself. Before we start, I would like to thank ESUG for giving me the chance to give this talk remotely, even though I couldn't make it there. All right. So let's talk about code coverage for a second to give a quick introduction. Code coverage is a technique used to measure how much code is actually executed when you run a test suite. The suite could be automated or manual. The way is that usually the coverage report is showing the values by highlighting in green the parts of the code that were executed and highlighting in red the parts of the code that were not executed under certain test suite. Okay, so now let's do the real presentation. I'm going to do it right here. So there are many ways in which coverage can be measured. I'm going to show some of them from the least precise to the most precise, to put it in that way. First one is method coverage. It's basically computed by counting the amount of methods in the solution, and then you check how many of those methods were actually executed. So in this example, as you can see, even though we have an early return here, the method is considered 100% covered. Of course, it's not very useful. That's why the next criteria tries to improve on that a little bit. This is line coverage, similar concept. You take all the lines that were executed and you divide that by all the lines in the solution. As you can see, these criteria accounts for the early return, but the problem is that if you have many statements in a line, they were all they're going to consider covered. even though again we have an early return here. So next one, statement coverage, trying to fix this. And this is same concept, but on all the statements in the solution. So in this case, we get what we will expect, right? The code that was actually exercised is the one that is highlighted in green, and the other code is highlighted in red. Statement coverage has some problems. I'm going to show one here in presence of conditionals. I'm going to exercise this case to exercise this method with true. In presence of conditionals, we get 100% coverage, even though this is not exactly right, because we have an implicit else branch here. This means that the code does not behave the same if this branch is executed or not. So this is one of the problems that statement coverage has. The next criteria is branch coverage is usually associated with condition coverage. I'm trying to simplify these criteria just for the sake of keeping this talk under 30 minutes. And branch coverage, that's what you would expect, right? If you had this case was true here, it will say that the code is 50% covered because we're using one case, which is the one that does not exercise this branch. So if I add an test case here and run it, then I get 100% coverage under branch coverage, right? Branch has an issue though, and is that branch only cares about the decision outcome, right? Where this whole expression evaluates to true or to false, but that doesn't account for the atoms in that expression or the conditions in that expression. So in this case, you can get 100% branch coverage, but branch coverage will mean that this collaborator actually affects the outcome of the entire method. So I'm going to show that right now. So I'm going to exercise this case to exercise this method with true and false. As we just saw, this we get a 50% coverage. If I want to get 100%, what I have to do is I have to exercise the false branch. So I'll go ahead and run this case to get 100% coverage. But if you notice in this case, I've added another boolean was always set to false, right? And in this case, another boolean affects the outcome of the method. So this is the problem that branch has. It only looks at the decision, and sometimes depending on the expression, you can mask the effect that some of the conditions has on the result. So the next criteria tries to improve on that again. This is condition coverage. When we talk about coverage, a condition is one of the many parts of a decision. And basically what condition asks for is that each condition to take all possible outcomes. In this case, it will be true and false, right? So if I add this test case, I'm going to set this one to true and this one to false. Now we are 50%. If I set the first one to false, and this one is 100% coverage and covered, and I'm still missing the test case for that one, and I can go ahead and do true here, and again 100% coverage under condition coverage. The problem about condition coverage is that, let me show you that over here, I'm going to reset this, is that you can get 100% coverage under condition. I'm going to put true and false here, and false, false and true. So both variables take on all possible outcomes. We got a 100% here, but if you take a closer look, the result of this expression is always true in this case, because at least one of the conditions is true. So we're getting 100% coverage under condition, but only the true branch is being executed here. So it's not, condition is not perfect. The next criteria that I'm going to show today, there are a lot more conditions, and probably a lot more that I don't know. This is called decision condition example. I was going to say decision condition coverage, and this one basically combines branch or decision coverage with condition. So this one kind of does what you would expect. accounting for the problems that we've seen so far. So we can add one test case to cover the false branch here, one test case to cover the true branch here, but because this criteria accounts for condition, we are still asked to cover the other two collaborators. We can do that. That's it by setting this one to true, this one to true as well. And this is how we get 100% coverage under this criteria. So one thing important to note though is that most tools out there only implement branch coverage, which is pretty low in the scale, to put it that way. And some of the tools don't even do that. As far as I remember, Squeak does method coverage, which is the first one we saw right here. If I'm not wrong, please correct me if I'm wrong. I believe that file right now does line or statement. I tried this example with latest firewall and I got 100% coverage with when I exercised the method true, so probably there's something missing there. IntelliJ IDE is support by default line coverage, which is pretty confusing. If you run coverage in those IDEs, you will see 100% and you will see totally fine, but then you find out that they don't enable branch by default for some reason, so be sure to check that if you use those IDEs. All right. And my motivation for this tool is that I was doing some work on this university, which is this distribution of Smalltalk I'm using right now, and the distribution that comes with a course tool, and I want to have something better than branch coverage. So what I implemented is what I just showed here, decision condition coverage, which is pretty precise if you compare it with most tools out there. You know, once that I implemented that, I started to think about all these analysis on volume variables, and I realized that we can do that not only for decisions, right, or for branches, but we can do that for collaborators as well. So in this example, as you can see, you will get a high-level overview on the method signature that will tell you that these two arguments were 50% covered. And the same goes for their usages. This kind of analysis can be done at many levels. We can do that at the temporary level. We can do that inside blocks. And one thing very interesting to note is that the conditional decision coverage criteria are usually defined on and usually languages that has those reserved keywords, but we don't have that here. And or are just messages. So that got me thinking, after some time that I implemented the conditional decision, I realized that any method that returns a Boolean could be considered could be a candidate for doing the same kind of analysis. So as you can see here, and is just a message, right? And besides Boolean being marked as 50% covered because I only set that to true, and it's 50% covered as well because you only took one out of the two possible outcomes here, and the same goes for the is 0, right? 0 is 100% covered because we evaluated that, and it's 0 returned true, so it's missing one test case, which is 0 returned false, so that's why it's considered 100, sorry, it's 50% covered here. Cool. So this is all I have for the coverage criteria. Again, there's a lot more out there if you want to keep digging into this subject. Okay, so I'm going to show you real quick how the tool works and how is architecture. Of course, the tool you can run it from the UI, run package trace with coverage, or run test with coverage if you don't want to run everything. I have a hot put here for a reason. I will talk about that later. The tool will do some kind of pre-process to the method that has been analyzed, and finally we'll run the test suite and give you the results on a regular browser level, because it's that the code will be highlighted depending on the coverage percentage, right? Like this one. have another example of the Boolean analysis. Okay, so how does this work? Well, first, the tool requires you to provide a set of methods you want to analyze. In this example, I'm going to walk you through. I'm going to be using this very simple method to keep things easy to understand. So I'm going to create a collection with just that method. And I'm going to create an instance of the main class of the tool, which is code coverage analyzer, passing all the methods I want to analyze. And the protocol for this object is value. It passes a block, and everything that runs inside that block will trigger the methods to be analyzed, to be tracked, and the coverage will be computed for the collaborations that are found by executing this block. So we're going to see that in detail. I'm going to debug this. So the first thing we have to do is to start tracking the code coverage. This requires some setup, and this tool has introduced the concept of a method analyzer. A method analyzer is an object that takes a compile method, I'm sorry, and recompiles the method adding tracing calls. So we can collect the information from those tracing events, and we can compute the code coverage for that method. So we're skipping abstract methods here because they are not supposed to be executed. We're going to talk about that later. And I'm going to show you real quick what a compile method analyzer looks like. Here we created one for this compile method that we want to analyze using this coverage analyzing. We're going to store it. If it's not already stored, we're going to store it here. And here we're going to take the source code of this method, and we're going to add tracing calls so we can know when a parse node is being executed. I won't go into detail here because this will be too long to explain, but basically I'm walking the AS tree and I'm replacing each parse node with an equivalent one, semantically equivalent one, but the one that I'm replacing that with takes care of notifying the coverage analyzer that something happened, right? Like this method was sent or this assignment was executed, that kind of things. And we replace the original method here. Okay. Let's finish this part. And now what we have to do is we have to provide a report builder that will take the information that is collected by these method analyzers and actually build a report. Report builders are configurable, and all the examples I just showed from method, line, statement, branch, all those flavors, those are just different report builders using the same code coverage tool. All right. So now we're going to finally exercise that method. And this is how the trace method looks like. So the first thing we notice is that we're sending some messages to this object. Even though this looks like a symbol, the actual value that is the object that is referenced is an instance of an object that actually ends up on the report builder to provide information about what happens. So in this case, the object reference is wrapped in a call. This basically emits an event that says, hey, this parse node was executed, and the positions that should be covered inside the method are those between 20 and 25. So as you can see, this one is not a symbol, of course. This is an instance of compile method coverage under fire. This one has a reference to one or more report builders, and basically it broadcasts what happened to the report builders. So report builders to do their thing. One thing interesting to note though is that coverage in this tool is based around wrapping parse nodes, and if a method is empty, there's nothing to wrap. So you cannot tell between an empty method that was executed from an empty method that wasn't executed. That's why each trace method includes this call at the beginning. So this makes sure that we account for that special case. Once we're done, we're going to roll back all these test methods, and we're going to actually build a report from the information that we collected. Cool. Once we're done with that, we can ask the coverage analyzer for the report, and we can open the browser I showed before to visually see the results of the analysis. Right? In this case, this was 100% covered. One very interesting side effect about this tool is that code coverage is usually very tied to TDD, but that might not be the case, and this is not the case actually. It could be a very interesting tool to help you understand systems. So I'm going to show you an example of that. I developed this other little tool, kind of a simple sport-like tool to do system-wide searches, right? Nothing fancy here. So what I'm going to do is I'm going to take all the methods from the tool that is called Finder. I'm going to create a code coverage analyzer with all those methods. And let's see that I want to understand how the tool works. So I'm going to manually start the code coverage analyzer, and I'm going to use the tool. Right now I'm running on the trace methods, right? Not the original ones. I do search, maybe I select the result, I close it, and I stop tracking code coverage. Now I ask for the report, and now what I get is maybe the person coverage doesn't help you very much here, but now you have a high-level view about which objects inside the Finder were used, and you can get a kind of a good start if you want to investigate how this all works. The class names catalog, which is the one that is used to search for class by name, it was 100% covered, so you have a very good candidate to start looking at. This is pretty interesting. This is a feature that Chrome has actually, which lets you use a web page and then it'll tell you which part of the source code were executed. So this is very useful and was a very nice side effect. Finally, let's talk about the most interesting part to me, which is reflection support. I wanted to be true to Smalltalk spirit and make the tool analyze itself. So I totally failed the first time I tried to do that. I ended up with methods that trigger an infinite recursion and the whole video crashed. So my first attempt was try to kind of identify and fix those methods. And even though I got pretty close to making it work, I quickly realized that even though I fixed those methods today, in the next release I might change other methods that now become candidates for infinite recursions, and then I will be back to square one. So this was a problem that bugged me for a long time, and I couldn't find a reliable solution. Until later I realized that there's something very simple that we can do to make this work. And I wanted to share that with you. So the problem here is that tools that try to analyze themselves, and what I did to make it work is basically a copy of the package. I copied every class, every extension method to a temporary package. I create an instance of the code coverage analyzer from that package, from the copied one, and that is the instance that is actually going to analyze the original one. So even though the original one will be recompiled and the methods will become these trace methods, nothing will break because the actual analyzer that is doing the work belongs to a different class, to a different package. So that was a pretty simple solution, and it actually works. And so that is what I'm going to show now. So this is the package. I'm going to run the package with code coverage. I have that hot here that we saw before. Again, we're creating a code coverage analyzer instance with all the methods from the code coverage analyzer package here. And this is the question. We're checking that if any of these methods belong to my category, then we are going to trigger this meta-analysis. Of course it does. So what we're going to do here is to grab my package, actually copy it. This is the tool I developed for that. It's called package snapshot. And then what I have to do is I have to ask the snapshot for the snapshot of the code coverage analyzer class, and the snapshot of the collaborators as well. Once I have that, I can finally send the instance creation method, but I'm going to send that to the copies, not the original ones. We have to pin this instance because it will get garbage collected to Solana to finally display the report and do some things there. And that's it. Now we have an instance of the code coverage analyzer we can use, and actually that instance is analyzing the code coverage itself, it's running the code coverage tools, test, sorry, and finally we get the code coverage for the code coverage. As you can see, coverage is pretty low, no, just kidding. Coverage is actually 84, 85%. This tool was developed using TDD. The reason this one is too low is because I'm packaging everything inside a single package just for making development easier. So we have a lot of UI code, which is the most mocked part of the solution, and the one that needs work the most. And we have some tests here and some helper objects as well. So I thought this was very interesting to share. Of course, scoping a package has some issues, especially extension methods are an issue, and reference to pools and that kind of things could be complicated but for this case, it works very good. And the nice thing about that is that you don't have to change the architecture of the tool to add this kind of reflection support to it. All right. Finally, some future work and open questions that I wanted to share with you. Going back to the Boolean analysis thing, one question here is that if it makes sense to make it for other kind of objects, not Boolean. I don't really know. It's probably too experienced, so it's worth trying out. The same goes for coming up with coverage criteria other than statements. For instance, I showed before that this tool ignores abstract methods because they are not supposed to be called. But we could define a criteria that considers an abstract method 100% covered if all of its implementers were executed or something like that. Again, I don't know if it's a good idea or not, but it's pretty cheap to try out. Delta coverage is a concept that I believe Kendrick talked about. The idea is here is trying to track which tests executed which parse nodes, and somehow compute out of the total percentage of those parse nodes which test affected the outcome the most. This would be very interesting to improve existing tools. For instance, the delete method refactor. We could check if we are building a test. We could check that how much the code coverage will be affected and which scenarios won't be covered if we are building that one. And we can display it to the user, and they can decide if it's the right thing to do. And finally, this is a long shot, but the architecture of the tool basically rewrites the AST of the methods. So we're very close to do something like before and after here. And we could do some kind of performance analysis, like taking the time each personal to run, that kind of things. It's not ready yet, but it's something that could be interesting to try out. In that case, you will have some kind of real performance analysis and sampling, that kind of things. So that one should be pretty fun to try out as well. All right, that's all I have. I don't know if we have time for questions. If you do, you can reach me here via GitHub or here via Twitter, and I'll be happy to answer any questions you might have. Thank you.